Okay, so we're on day 8 notes, and we're going to talk about the Pythagorean, not theorem, but identity, but it comes from the Pythagorean theorem, okay? So it says, since each point on the unit circle must satisfy the equation of the unit circle, which is x squared plus y squared equals 1, because the center is at 0, 0, and the radius is 1. We get that for our equation of our circle. We can now state that what is known as the Pythagorean identity. Okay? So in number 1, it says, using the triangle from the unit circle, find the ratio for each of the following. Okay? So in our small triangle here that we've been using in our unit circle, remember that this is x, and that this is y, and that this is 1. Okay? And that when we read from angle theta, that this is our opposite side, this is our adjacent side, and this is our hypotenuse side. All right? And if we're doing cosine theta, remember cosine theta is adjacent over hypotenuse. And so our adjacent side ends up being x over our hypotenuse side, which is 1. And therefore cosine theta equals x. And we've been working with that for a while now. Sine theta is opposite over hypotenuse. And so our opposite side is y, over our hypotenuse side, which is 1. And then we end up with sine theta equals y. All right, so we've known that for a while. But now we're going to do something a little different. We're going to take these values and substitute our answers from part A into the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. Using our right triangle over here, that would be x squared plus y squared equals 1 squared, which is 1. Okay? And then if we replace x with cosine theta squared plus replacing y with sine theta squared equals 1 squared, which is 1. This right here is known as the Pythagorean identity. Okay? So coming down here, it says for any angle theta, cosine theta squared plus sine theta squared must equal 1. Okay? They can also rewrite it where the squareds are on the actual trig functions, all right, and then not in parentheses. I prefer this look of the Pythagorean identity, but you might also see it written like this, which I think is a little confusing for you guys. Okay, but they could also write it like that. All right. Here's how we can use that. Okay. In number 2, it says using theta equals 60 degrees, verify the property. And so they're using this look, but we're going to rewrite it, okay? So as soon as we see that, they also switched around the sine theta and the cosine theta, which is fine because there's addition between them, and so you could switch them. So this will be sine theta squared plus cosine theta squared equals 1. And they're saying theta equals 60 degrees, so we'll go ahead and replace it. So this will say sine of 60 degrees squared plus cosine of 60 degrees squared equals 1. Okay? And now we'll go ahead and type it in our calculator. Sine of 60 degrees, when you type that in, you're going to get 0.866, ... So just remember that that's the square root of 3 over 2, and then we have to square it. Okay? Typing in cosine of 60 degrees, that's 0.5, which is 1/2 squared equals 1. Okay? And now we're going to go ahead and square them. So remember that the squared has to be used not only on the square root of 3, but also on the 2. And so the square root of 3 squared is just 3, and 2 squared is 4. Okay? That this squared here has to be used on the 1 and on the 2. So 1 squared is 1, and 2 squared is 4. And when we add the left side together, 3/4 plus 1/4 is 4/4 equal to 1. And 1 equals 1, and we just verified our property. Okay? So it works for any angle theta that you can put in there. All right, so where can we use it? Well, we already have a method that lets us find the exact value of cosine or sine, depending on which one we're given and which one we're looking for. But now we just have another method, okay? So we like to use the triangle method. We already know this one, okay? So I'll use this one first just to show you that you already know. So because we're giving sine x equals square root of 5 over 3, and this is sine, this is the opposite, and this is the hypotenuse. Okay. They also told us that our angle X is in quadrant 2. And so when we graph this out, to get into quadrant 2, we have to go to the left and up and then back. We'll put our right angle, we'll put our theta in there. This would be my opposite side, my adjacent side, and my hypotenuse side. And according to what we were giving, opposite is the square root of 5, and hypotenuse is 3. And we can go ahead and use the Pythagorean theorem to go ahead and find our adjacent side so we can find cosine x. So we can put the square root of 5 in for A, and we'll put the hypotenuse, which is 3, in for C. Okay. We end up with 5 plus b squared equals 9. If we take 5 away, we get 4, and therefore b comes out to equal 2, which is our adjacent side. And now we can go ahead and say that cosine x, or cosine theta, doesn't matter, equals your adjacent side, which is 2, over our hypotenuse side, which is 3. And then we have to just check the sign. So all students take calculus. Sine theta is positive, and therefore cosine theta is negative, and so we have to add in a negative in order to have our correct answer. All right. If we use the identity, we are get the same exact answer, just a little bit different finding it. So we'll go ahead and use Pythagorean identity to find it. And so we'll write that down first. So cosine theta squared plus sine theta squared equals 1. We are solving for cosine theta, so we're going to leave this. Sine theta, though, is the square root of 5 over 3. And we'll leave this again. But we'll square this out. So remember that the squared has to be used on the square root of 5 and the 3. So square root of 5 squared is 5, and 3 squared is 9. We're going to go ahead and subtract 5/9, and we end up with cosine theta squared equals 4/9. 1 minus 5/9 is 4/9. To get rid of the square, we're going to go ahead and square root both sides so that cancels. And we're left with cosine theta equals, now because you even rooted both sides of the equation, technically this is plus or minus. The square root of 4 is 2, and the square root of 9 is 3. And then we still have to talk about all students take calculus, just like we did on the other side, to realize that in quadrant 2, sine theta is positive, and cosine theta, therefore, is negative. And so there's that same exact answer on the other side. All right, we don't want the positive on this one. So we kind of reject that positive 2/3. All right, so just 2 different methods to get that answer. All right, guys, I'll see you on the back side of the notes for a little bit more practice with the Pythagorean identity.